The day an apple told the truth. It all starts with a story, a simple one. Picture a quiet English garden in the late 17th century. A young man beneath a tree, lost in thought. An apple detaches from its branch. It falls, it lands with a soft thud. For most, a non-event. For Isaac Newton, a spark. It was the universe whispering a secret. He didn't just see fruit falling, he saw a question. Why did it fall straight down? Why not sideways? Why not upwards? What invisible force pulled it to Earth's center? That question set a lifetime of inquiry in motion. A quiet boy with a big mind. Isaac Newton entered the world prematurely on Christmas Day of 1642 in the small hamlet of Woolsthorpe, England. He was a small and frail infant, not expected to survive. His father had died before he was born, leaving his early life marked by absence. When he was 3, his mother remarried and left him with his grandmother. Separation bred independence and a preference for solitude. He found companionship in thought and creation. The barns of Woolsthorpe became his first laboratory. Others played or did chores. Isaac built and studied. He was fascinated by how things worked. He built intricate models and contraptions from scraps, tiny windmills, powered by a mouse on a treadmill, a water clock that kept accurate time, sundials so precise his neighbors relied on them. He flew a lantern on a kite, mistaken for a comet. Patience, precision, and a need to see inside systems defined him. He was not made for farming. His destiny lay with ideas. Recognizing he wasn't a farmer, his family sent him back to school. He returned to the King's School in Grantham. At first, he wasn't a standout. Quiet, lost in thought. A confrontation changed him. He resolved to excel. He applied himself with fierce determination, quickly rising to the top. He lodged with William Clark, the local apothecary, a house filled with books and chemical supplies. He experimented, mixing, observing, noting reactions. He filled notebooks with observations, drawings, and ideas. Teachers saw extraordinary potential. He should attend university, not return to the farm. He excelled in Latin, Greek, and biblical studies. But his true passion was mathematics. He explored the structures beneath numbers and shapes. From clever models to abstract mastery, Grantham forged his identity and set his path. He was ready for Cambridge University. Trinity College, entry to Cambridge. In 1661, at 18, Newton was admitted. He arrived as a sizar, working to study. His humble status reinforced solitude and study. Cambridge still taught Aristotle and geocentrism, heavens as perfection, not forces. Yet across Europe, a revolution brewed, and Newton drank deeply. He interrogated, not just read. His certain philosophical questions became a battleground. In 1665, the Great Plague shut Cambridge. Newton returned to Woolsthorpe for nearly 2 years. Forced isolation, his most fertile period. He began forming the foundations of calculus. He proved white light contains all colors, apple and moon, one force governing both. He came back no longer a student, already a pioneer. He held secrets that would reshape the world. The stage was set. After years of private contemplation, Newton forged a coherent system. The first pillar, 3 laws of motion, later published in the Principia. First law, inertia. Motion persists unless a force acts. Friction and gravity change motion, not nature's preference for rest. Second law, F equals ma. More force, more acceleration, more mass, more force required. This law became the heart of physics and engineering. From rocket thrust to crash forces, we can calculate a universal tool for a world in motion. Third law, every action has an equal and opposite reaction. Forces come in pairs, gas down, rocket up, into space. Recoil, flight, even a bird's wing beat, reaction in action. For the first time, reliable math described everyday motion. The world revealed itself as a grand machine. Stronger bridges, efficient engines, accurate trajectories. Newton gave us the operating manual for the physical world. Of all Newton's discoveries, none captured us like gravity. The grand synthesis, heaven and earth connected. The force that pulls an apple down keeps the moon in orbit, and Earth around the sun. Gravity, universal. Every object attracts every other object. The force depends on two things, their masses and their distance. He demolished the wall between heaven and earth. The sun and Jupiter, same kind of pull as a book and a table, different scale. From pebble to star, the universe plays by one rule. He captured it in an elegant equation, proportional to masses, inverse to square of distance. That inverse square law explains weakening with distance and Kepler's ellipses. When Uranus wobbled, math predicted Neptune, and telescopes found it, mathematics revealing new worlds. While motion and gravity made him famous, his work on light was revolutionary. The old belief, color, was a modification of white light. Newton tested it himself. Sunlight through a small hole, then a prism. The prism split white into a brilliant rainbow: red, orange, yellow, green, blue, indigo, violet. His critical experiment: isolate a single color and test it again. The prism didn't add color. Red remained red. Recombined colors formed white again. Proof complete. Each color bends at a slightly different angle. Lenses blur colors, chromatic aberration. His answer: a reflecting telescope. Mirrors reflect all colors equally, sharper images. That design still powers our greatest eyes on the cosmos. He changed how we see and what we can know, onto the mathematics of change. To describe a universe in motion, Newton needed a new language. Algebra, geometry, trigonometry, great for static things, poor at change, motion, and curves. He invented a new branch, what we call calculus, built on two powerful ideas: differentiation and integration. Differentiation, instantaneous change, slope at a point, the exact speed at the exact moment. Integration, accumulating totals, distance, area, change. Newton proved their inverses, the fundamental theorem. Leibniz developed it too. Newton forged it to solve nature. Today it underpins science, engineering, economics, technology, from spacecraft to suspension bridges to computer graphics. Newton died in 1727. The world was altered. Before Newton, inquiry was philosophy and superstition. After Newton, rigorous, mathematical, predictive. Hypothesize, test, describe with math, predict. We send satellites and probes using his laws, from a baseball pitch to a car engine to daily life.